So welcome to the webinar. This is the optical gas imaging real-world applications for methane emissions compliance. I'm Sue Davis. I'm the marketing director at Sierra-Olympia Technologies, Inc., and we're really pleased to be partnering with the Micropilot UAV Manufacturers Meetup Series. So this series started as a way for the UAV industry to connect remotely during COVID, but there continues to be a lot of enthusiasm for this series. There's actually a full day of programming tomorrow. So this is kind of the end of the day today because the time zones began like at 5. So there have been webinars starting at 5. So this is kind of the conclusion of day 1, but there is another full day of programming tomorrow. So I will be sharing a link in the chat in case you would like to sign up for any of the other webinars that will be tomorrow. So just be aware that today we are recording the webinar. At the conclusion, we'll send out a link to the webinar just for reference, and it'll be available on our blog, of course, as well. So the intention for this webinar is that it be practical, educational, and enjoyable. So we really want to encourage people to ask questions and for the panelists to ask each other questions as needed, because you guys are all coming from different points of view. I will be monitoring the Q&A, so if your question does not get answered live during the webinar, just know that we will circle back and answer those questions by email directly to you. So I want to do an introduction of our speakers, and the first thing I will note is that our president, Chris Johnston, is not able to join us, but we have our chief engineer, Stan Voynick. So Stan entered the industry in 1987 in the Santa Barbara area, in the infrared community based around Hughes Aircraft's Santa Barbara Research Center. He started at Amber Engineering, developing one of the first commercially available indium antimonide INSB camera systems. Amber was acquired by Raytheon, and subsequently Stan spent some decades as a technical consultant in the industry. And he joined us here at Sierra-Olympia as chief engineer in 2016. Jeff Leake, he is internationally known for his expertise in optical gas imaging technology and implementation, and he's our VP of sales here at Sierra. He's been on the ground level of many of the industry's innovations for decades and is an advocate for the technology as an important solution for improving industry practices and curbing fugitive methane emissions. Jennifer Mattox is with us from the Colorado Department of Public Health and Environment. She has led the program's inspection team overseeing air quality compliance for the oil and gas industry in Colorado for 10 years. She's overseen the Colorado Approved Instrument Monitoring Methods team for the last 8 years, and their work is to evaluate new monitoring detection technologies and working with the monitoring community regarding use of these technologies. So one important note here is that we really appreciate having Jennifer with us today and want to be totally transparent and clear. Her participation is educational. It doesn't imply an endorsement of the Sierra-Olympia optical gas imaging solutions over those offered by other companies. So her knowledge and experience are just enormously appreciated. So I'm going to turn it over to you, Stan, and feel free to add a little more of your story because I just gave a really quick introduction.
I just sent that to Sue a few minutes ago, and you did a great job with indium antimonide. So yeah, I'm Stan Weinick. I'm chief engineer, and I send apologies from our president Chris Johnston, who was unavoidably offline today. I know he's disappointed he won't be able to participate, and I'm sorry that you ended up with a second tier in me, but I'll do my best here. Yeah, I mean, Sue said most of it. I've been in the industry since about 1987. The infrared industry, a strong and important segment of the infrared industry, grew up around the Santa Barbara area, which was an awfully nice place to be, and around an offshoot of Hughes Aircraft called the Santa Barbara Research Center. And the folks that I worked with there were all kinds of offshoots of Santa Barbara Research Center. A little tiny company that I started in called Amber Engineering was one of those. We ultimately got acquired by Raytheon and continued developing things like, and Jeff Leake will remember this, the first indium antimonide cooled MidWave infrared system. the technology on which many of our products and the ones we're going to talk about today with optical gas imaging are based. At that time, instead of being small, nearly handheld devices, these were what we call pore fill dewars. We poured liquid nitrogen into the top of these things to cool the sensors down to the right temperature to operate. And it was great fun with the vapor coming off, and we were playing with liquid nitrogen around the lab and seeing what it did when you rolled it across the floor and stuff like that. It was a big deal at the time, Jeff, again, you'll remember this, big deal at the time to get an array that was as large as 128 by 128 pixels. You'll get a sense that the industry has come a long way since then. I went off on my own for a while, continued working with Sierra-Olympia through its founding and so on as an independent contractor. And then in 2016, I joined up as we started to Sierra started to further broaden our marketplace. We had traditionally been I'll go into the Sierra-Olympia story now. Sierra was started in 1995, which is about the time that I went and became an independent contractor. And it was for a fair period of time a manufacturer's representative and a sales channel for all of these new and developing infrared technologies. Over the past decade, we have very intentionally turned into a development organization where we are developing our own products. We work with large leading edge sensor manufacturers, and we typically take their technology that they're developing maybe for government contracts or for other things, and we bring them to the market in a way that is usable and able to be integrated easily by engineers in companies who are working on what I consider to be the neat stuff. You know, putting a lightweight, highly capable sensor on a small multi-rotor uncrewed vehicle, a drone, to be able to go and do some interesting things. Much of the things that you'll be hearing about from our other speakers here. Over this time, since Sierra's founding, we've integrated probably something like 3,500 cooled MidWave sensors. And I'm going to be careful about how I know we have a wide range of our audience here, but certain infrared sensors need to, in order to work in certain areas of the infrared spectrum, need to be cooled down to almost liquid nitrogen temperatures, those cold temperatures I was talking about before from the old days, and we used to literally pour liquid nitrogen into the top of a cooler to get them cooled down. These days, that cooling function is performed by a small refrigerator. I use that term intentionally. It's much like the refrigerator in our kitchens. It has a compressor that compresses the working fluid, and heat is transferred and so on. These very compact refrigerators are able to do that job of cooling the sensor down so that it can image properly. Sierra we've integrated probably 3,500 of these MidWave cooled sensors over the past couple of decades. So we have deep and broad experience in this area. My specialty being chief engineer is the technology. So I'll give you a brief overview of the optical gas technology, starting with that as the background. But those sensors see in a certain range of the infrared, just like our eyes see red, orange, yellow, green, blue, indigo, violet. That's the range of wavelengths that our eyes are sensitive to. If you move just a little bit off of their infrared, underneath the red color, is the infrared region, and in a specific, it's in a region. Let me get myself straight here. It's in the 3 to 5 micron area of that region that cooled sensors are sensitive to. Just like our eyes see from red to purple, cooled sensors see from 3 to 5 microns. That's how we describe their color range, if you will. Within that range, there's an even narrower range, right around 3.2 microns, that all of the long chain hydrocarbons with these carbon hydrogen bonds in them. Thank you, Jennifer. I've always thought I was getting that right, and I'm just making Jennifer's nodding. That reassures me. I believe it's the carbon hydrogen bond in these long chain various hydrocarbons, which have an emission and an absorption peaks right in that 3.2 to 3.4 micron range. So we have further enhanced the MidWave sensor by putting a filter in there, a very narrow filter that only sees that narrow range. That would be akin to, say, if I'm looking at a scene with my eye, seeing red, orange, green, blue, and so on, putting a red filter in front of my eyes so that all I see all I see is the reds coming off of things. By doing that, we make our sensors very sensitive to that range where hydrocarbons will absorb infrared energy. And so what the result of that is that if there is a plume of hydrocarbon, let's call it methane, that's the easy one to talk about. If there's a plume of methane coming out of a valve or some leak somewhere, when I image that area with an optical gas imaging sensor, like one of these ones with the narrow filter in it, I will see that plume absorbing whatever would be coming towards me from the background. And that plume, depending on actually whether that plume is a cooler gas or a warmer gas, it can appear either as a dark kind of a shadow absorbing the brightness coming from behind it, or it may appear as a bright plume if it's hot gas and warmer than the background. Either way, these now exquisitely sensitive cameras can image and pull out and let us see what is not otherwise seen. These plumes might be completely invisible to the naked eye, to the human eye, seeing in the red to purple range, but they pop right out in the case where we have these OGI cameras. Sierra-Olympic has continued to push this technology forward and develop it. We are making it always smaller, lower power, lighter weight. And these three things, you'll hear the term in the industry often, you'll hear the term low SWAP, SWAP, size, weight, and power. All three of those things are critical in applications like I talked about, like an uncrewed vehicle, a drone, the small multi-rotors. You see the kids out in the parks with these little multi-rotor drones. It doesn't have to be much bigger than that to be able to lift an infrared payload and be able to go do some useful stuff. I think Jeff will probably get into this. I don't want to step on either of our next panelists' points here, but we're always looking for ways to deliver imaging capability into places that either it was hard to get to before or dangerous to get to or something like that. If you have to send a crew up on a scaffold or up the side of a cracking tower. See, now Jeff, I'm just making stuff up, but up the side of a cracking tower in a refinery or something like that. You have to go through safety protocols and paperwork and so on in order to make sure that crew stays safe and that it's a known plan and a known mission, and they carry it out safely and accurately. That's absolutely critically important. If, on the other hand, you can send a small multi-rotor drone up, there are of course still safety protocols and so on, but you can keep the crews further away. You can stand off and look at things. You can also do those things more often and on a more regular basis, so that you can tend to catch things sooner, and just all of these things enhance our ability to again, I'll go back to the term, to see what would not otherwise be seen and catch these things and catch these leaks. I think I'm going to go ahead and pass it on from there, and because I think our other panelists can talk much better than I about the regulatory implications and the things that are certainly there's an awareness both in the public and in the regulatory realm of needing to keep an eye on leaks, fugitive emissions, and so on. These things they both drive us to develop our technologies, and our technologies inform the ability to make regulations. If we can see things to a certain degree of sensitivity, then that lets us know what we can regulate. And as the regulations come along, we meet them with the development of our technologies and the ability to gain compliance in a good, efficient, and safe way. So I think from there, Sue, if it sounds good to you, I think I'll pass it over to Jennifer. And
that sounds great, actually.
Listen with interest to what our other panelists.
Okay, good. I was just going to ask you, I know you are joining us in Chris's place. I wasn't sure if you could stay for the whole webinar. If you can, we'd love that.
I would love to, yes. And I was joking with Sue that this is a little bit like that old nightmare you have where you walk into your final exam and you realize that you have not been to class for the whole semester. And so but I'm glad to be able to participate, and I would love to stick around and listen in.
That's great. Thanks, Dan. Yeah, we appreciate that very much. So I'm going to launch a poll, and this is, Jennifer, I'll let you kind of get your plan together, unmuted, and slides ready. But if you guys could. Let's just 1 second here, sorry. I have a very quick poll here that kind of will help Jennifer think about who you all are and structure her comments in ways that are reflective of that. I hope everyone can see that poll. And be able to participate. Oh, good. Here we go. People are joining. Thank you.
And I'll note that I saw it covered up for a moment when you did a screen share, but I was able to just move the poll window off to the side. And so if that's a possibility too. If anybody wants that poll window for a moment there.
Okay, that's great. And I will give it just, probably another like 30 seconds, and then I can share the results of the poll so we can all kind of see who's here. Looks like the majority of answers as far as what your role is in the industry is other. So if you care to put a comment in the chat window to describe what that other role is, feel free. Okay, so I'm going to end the poll and share the results. Can you see that, Jennifer? Okay, great.
Thank you.
So probably, yeah, as I mentioned, 50% of the people are in the other category. The next largest is service provider. And then it looks like about 46% of folks have never used OGI technology. About 23% use it regularly. So, okay, I'm going to stop sharing that poll and I'll let you take over, Jen.
Okay, thank you, Sue. Is my screen sharing okay?
Yes, it looks perfect.
Excellent. Thank you so much for having me on this webinar. I'm happy to share Colorado's experience. My name is Jennifer Mattox. I am a Compliance Oversight and Inspection Supervisor here at the Air Pollution Control Division of the Colorado Department of Public Health and Environment. As Sue mentioned, I also lead the Alternative Approved Instrument Monitoring Methods team. I'm here to give you a high-level overview of Colorado's experience with IR camera use, which includes optical gas imaging. So let me set the stage for Colorado's oil and gas environment. We have a very dynamic environment for oil and gas due to the different basins. If you're not familiar, we have 4 producing basins that are the largest sources of methane and other volatile organic compounds. The Denver-Julesburg Basin is in the Denver Front Range, and it's a largely hydrocarbon liquid producing basin. The Piceance Basin on the western slope of the state produces a lot more dry gas, not as many hydrocarbon liquids. We also have a coal bed methane seam producing only coal bed methane in the Trinidad area. And finally, the San Juan Basin in the southwest portion of the state, which is an older, more established basin. It could be considered on decline at this point in time. And so with those type of basins, our regulatory environment is one of the most stringent in the country to date. We were one of the first to adopt methane regulations in 2014, consistent with the adoption of approved instrument monitoring methods, which employed the IR camera at that point in time.
Jennifer, have you advanced slides? Oh, there we are. Okay, thank you.
No, that was my introductory, Sue. I'm going to advance them now. So let me start with, what is AIM? Well, AIM is the approved instrument monitoring method, which means EPA reference method 21, an infrared camera or instrument-based monitoring method approved by the Air Pollution Control Division. And we defined an IR camera as an optical gas imaging instrument designed for and capable of detecting hydrocarbons. It's a very important point because our definition includes the hydrocarbon range. So not just methane specific, but volatile organic compounds all the way down the hydrocarbon chain. As you can see in our definition of AIM, IR camera is included. These are the approved IR cameras that we've evaluated their specifications and determined that they meet the definition of IR camera and AIM under Colorado Regulation number 7. And as you can see, several models are up there. These are the cooled cameras. So what Sian was talking about before, they need a cooled area to cool the sensor itself. And again, I do have to mention, we do not sponsor or require the use of any specific model of camera. That's why I'm laying these out here for you. These are already considered part of AIM in the Colorado regulatory environment. So what do we do with this? So we employ it to observe and reduce emissions from oil and gas facilities as required under Colorado Air Quality Regulation number 7. That includes a host of different activities, which include well production facilities, compressor stations, and then storage tanks at E&P production, exploration and production facilities, Class 2 disposal well facilities, well production facilities, natural gas compressor stations, and gas processing plants. We also use it to evaluate continued and proper operation of pneumatic controllers at all these types of facilities. So Colorado has employed the IR camera in its compliance strategy for about 10 years. Our experience originated with our joint investigative work with EPA Region 8. They obtained an IR camera, and we conducted research with EPA in 2011 and 2012. And in 2013, based on the findings and our report back to the legislature approved funding for a 2-year pilot program to identify and address emissions from the oil and gas industry. And in 2014, we codified the use of IR camera in our leak detection and repair and storage tank emission management programs. And then finally, 2015 is when we first had companies, operators who were employing either IR cameras or reference method 21 submit leak detection and repair reporting. And that has been evaluated every year for how leak detection was completed and the success of reducing or minimizing emissions. In 2017, we also codified the criteria that we'll use for evaluating alternative AIM. I would say that many of the non-cooled options of IR cameras are in this value because they only monitor methane, or their capacity is limited to methane. Sorry if I said that wrongly for the manufacturers here. And so we included that in our regulation number 7 in 2017. But throughout our initial use of the IR camera, we've continued to use it to monitor the emission rates and use our IR inspection data on a monthly and quarterly basis to evaluate trends in minimizing emissions from fugitive components. Our inspectors complete anywhere from 1,200 to 1,500 inspections every year using the IR camera. We employ 11 cameras here at the state. And in our experience, the IR camera is rather versatile. It could be potentially used to detect hydrocarbon emissions visible in the established wavelength of the camera from any source of hydrocarbons. And so we use this information And we began to employ it at fuel dispensing facilities to determine proper operation. That's been largely successful in reducing emissions and reducing improper operation for those type of pieces of equipment. And secondly, the IR camera observations that we did initially from 2011 to 2013, or maybe 2015, established the basis for Colorado's first and one-of-a-kind vapor control system guidelines for atmospheric storage tanks. I encourage you to look at those. If you just Google that on the web, or just Google it, you should be able to come to those guidelines. Easy peasy. And then in 2018, operators have fully adopted using the IR camera in the field, and they continue to use this predominantly in exploration, production, midstream, as well as pre-production monitoring. We required the use of pre-production or the use of monitoring to establish pre-production emissions during those type of operations. I mentioned alternative aim and that the cooled cameras would probably, or non-cooled cameras would probably fall within this criteria, or right within this arena. Our aim process includes an opportunity for other monitoring technologies to receive approval to use as a monitoring mechanism. The approval process is largely modeled after the alternative means of emission limitation criteria that were established in New Source Performance Standards Quad O and Quad OA. I hope you are familiar with those, but that is the large federal regulation applying to the entire oil and natural gas industry. And if you're interested in understanding what that approval process is, I do encourage you to go to our website that is located at the end of this presentation. And Sue, I'd be happy to have these presentation slides shared with your community. That's not a problem. So that you can go and evaluate our website and all the work that we've done there. But one thing I did want to point out is that the process for approval can be long. And if you'd like to speak with me or the AIM team about that, you can definitely do so and reach out, and I'll provide a contact information. We have 2 approved alternative aims. Guess what? They're both cameras. So it's the Rebellion, now Honeywell gas cloud imager, and the Pixel Velocities fixed automated leak detection system. Both of these letters of approval and conditions for use are located on our website as well. It's a wealth of information about how we monitor emissions from oil and gas facilities, so I highly recommend that you visit it. So that's kind of my high-level presentation for you. And I just wanted to share a couple of things offline with you about lessons we've learned over the 10 years in the 8 years employing the IR camera. I mean, a picture says 1,000 words, right? So video documentation provided a foundation to successfully address atmospheric condensate storage tanks. With over 13,000 active oil and gas wells in the state of Colorado, there's quite a few storage tanks out in our state. And these, we used IR camera inspections to successfully secure design, operation, and maintenance to make sure that these facilities are not venting from 10 of our highest producers in the DJ Basin. So a lot of emission reductions associated, and thankful for documentation provided using the IR camera. And again, we've also used it in stage 1 vapor recovery gas systems at gas stations since 2018. And we've been largely successful in reducing the rates of venting from these pieces of equipment and ensuring proper operation of those as well. And Colorado is now exploring ways to incorporate the IR camera into use with other monitoring technologies, such as aerial and truck mounted and fixed sensor monitoring, to assess rates of emissions, also potential health impacts based on the culmination of data collected, and any emissions observed by the IR camera. We are right at the infancy stage of this work, so this is just beginning. Really excited to see how the IR camera can complement or collaborate or assist with monitoring, reducing, and minimizing emissions from these type of facilities. And so, like I said, our AIM webpage is on my presentation here. and a general form of contact. We do have a general inbox that is overseen by myself. Happy to answer any questions and speak with you at another time. And I appreciate so much the opportunity to share our experience here, Sue.
Thank you, Jennifer. I will put your information into the chat window. For now, let's put questions into the chat, and then at the end, I will share those with everyone. I'm going to do one more quick poll, and you can probably stop sharing now, Jen, and we'll get Jeff started. Let's see here. This is more related to information that's really useful for us. And it is, I'm going to launch that poll now, and I'll let that hold for about a minute. And then I can share the results with everyone.
Sorry, Sue, I'm just having technical difficulties. There we go.
Okay, no worries.
I apologize. Thank you.
Thanks for that great presentation. Okay. I'll give it about 20 more seconds to drop your answers into that poll, and then I'll share the results. And again, if you're in the other category in any of these questions, feel free to put a comment in the chat to tell us more about that if you would like. Okay, so there we go. I'm going to share that with everybody. It looks like airborne multi-rotor, airborne fixed wing, handheld, a bit of continuous monitoring, some robotic kinds of activities. Looks like OGI is a service for other companies, regulatory inspections, research and development. I'll monitor the chat for information on other, and then just whether you're looking to do this kind of work in 22. Okay, so I'm going to stop sharing that. Jeff, I'll let you take over.
Okay. All right, everybody hear me okay? All right, great. So my name is Jeff Leake, and I'm the Vice President of Sales for Sierra-Olympia Technologies. As Stan mentioned, I am a veteran in the infrared industry as well. I have been involved in business development for infrared imaging camera system since 1984. And in starting in the mid-90s, got actively involved in the development of the first optical gas imaging camera systems with a company that was based out of Central Texas. And that formed what we have today. That was the beginning of the process, basically. So optical gas imaging is near and dear to my heart, and into the opportunities that that it's afforded for in general the infrared industry. So I was going to kind of carry on from what Jennifer and Stan kind of talked about. And this is going to be a little bit more focused on the technology and the applications of the technology, and how we've mainly been focused over the last 20 years, basically, with the use of optical gas imaging for handheld portable use. And over the last 3 to 5 years, especially with the introduction of products like the Ventus optical gas imaging system, that it has enabled us to be able to really expand into many other application uses. So we're going to touch on those things here. So let's make sure that we can advance. There we go. Stan already touched on a number of things about the baseline of technology, but I'll just mention some things here related to advancements in the sensor technology from when we originally started with the base indium antimonide or INSBE-based infrared detectors that were originally and still used today for mid-wavelength optical gas imaging cameras. So some of the changes, and most recently in the last 3 years, is that we've moved away in some manner from the INSBE-based detectors to now what are referred to as hot mid-wave infrared detectors. The difference being there, Stan mentioned previously, the INSBE detectors are based on operating at 77 degrees Kelvin or cryogenic temperatures. Hot mid-wave detectors use the base of an INSBE detector, but they have different depositions of additional materials. And because of that, they can actually operate at a higher operating temperature. So they do not have to be at cryogenic temperatures of 77 degrees Kelvin. They can be more at about 150 degrees Kelvin. The benefit of that is that you can, again, as Stan mentioned, reduce size, weight, and power, especially of what is referred to as the integrated Dewar cooler assembly. And that third line there talks about the extended life of a cooler. This is that refrigerator that Stan was mentioning, basically. Previously, that INSBE-based sensors and the coolers were typically rated to about 7,500 to 10,000 hours. So a benefit of being able to operate at a higher operating temperature is the cooler doesn't have to work as hard. And the benefit of that is then it extends the operating hours. This becomes really important for those continuous monitoring applications that was mentioned by Sue. So you want to fix mount these systems now on a pole, outdoors, continuously monitoring. You don't want to have to be servicing those coolers every year. You want to get as extended life out of those as possible. So all of those things help by having this smaller cooler and enabled us to be able to significantly reduce the size, weight, and power from traditional 3 to 5 pound type of systems down to about 1 pound. And so whether that translates into a handheld use, makes it, obviously more comfortable for an operator, or by integrating it and making it available to these unmanned aerial platforms. Again, weight is everything because it relates into flight time. And everybody is interested in increasing flight time and having as low as weight payloads as possible. So in addition to that, another thing that's happened over the last few years is we've moved from what we call quarter VGA resolution or 320 by 256 to now sensors that are VGA resolution or 640 by 512. And so now you have about 4 times as much resolution of the traditional sensors that have been used in this application for many years. We've reduced the pixel size as well, but maintained the sensitivity. And by having high resolution, as you'll see examples of the imagery, the sharpness and the clarity of the images is significantly more. And that translates basically into the ability to either visualize smaller leaks or to be able to use the cameras from further distances and still be able to detect these smaller leaks, which is then expanding the capability from under the Quad OA requirement of the 60 grams per hour of being able to detect and visualize that over traditional 320 by 256 sensors. And by having this better resolution and better sensitivity is enabled us to be able to be able to do these kinds of inspections from further distances. And then, as Sue said, these certainly meet the Quad A certification. And then each of the individual states, as she mentioned, has their own validation requirements. So this is one of the applications that's been being done with infrared optical gas imaging cameras for many years, and it's a manned helicopter inspection. This is a service provider, and hopefully everybody can see this. This is, again, because of the small size of the camera, can be integrated into a gimbal. This happens to be a Robinson 44 helicopter. And so this is for more wide area inspections. So this kind of an application is for servicing, things like linear assets or pipelines, or being able to do like a whole basin area Sue mentioned. So when as Stan described, that kind of dark cloud that you're seeing coming out from the vents, for instance, that is the vent in the hydrocarbon gas being vented out. It can be either from an Arnardo valve, can be from a flare, it can be from, just pore seals, these kinds of things. So obviously in a helicopter-based system, they can integrate this with a visible light camera. And by being able to do simultaneously the OGI image and the visible light, it makes it easier for those who come back that have to service and repair these things to be, able to know precisely where that leak is actually emanating from and what the point source of it is.
Hey, Jeff, can I interject one real quickly here? On your video, I think it's probably an effect of the fact that we're screen sharing right now. These videos are showing up, at least at my end, at only about a frame or two per second.
Oh, really?
I want to point out that you can see the plumes in these videos. However, it's not quite doing it justice, unfortunately, because when you can see these things at full video rates, and that's where the video really comes in, is when you're looking at these things at 30 frames per second.
Yeah,
those plumes just pop out. They're really obvious. So we could see them in these. It was almost like a series of still photographs, but the video itself is even more compelling than what you're seeing here.
Okay, thanks, Stan. Appreciate you seeing that, because I can't see it from my end. Obviously, it's playing very nicely. Some of these other, so just expanding on the application. So we had a manned or crewed or piloted type of application. This is just a real expanding area of the use of optical gas imaging, and this has to do with uncrewed aerial systems, and it comes in a lot of different formats now. The top two pictures, for instance, indicate more of a traditional kind of quadcopter. People are probably very familiar with the one in the upper left. That is from a company called DJI. It's called the Matrice 300. They have a similar product called the M210 version 2 prior to that. And at the bottom of it, on the in the gimbal there, basically, which is the you have the Skyport gimbal and the export. The camera is then integrated into that, and then the operator simply uses the traditional DJI controller and DJI Pilot app. So as soon as that camera gets connected into the UAV, it automatically recognizes the camera and ports over all of the command and control and the video feed link, basically, that Stan described at that 30 frames a second. So you can use this now to cover a lot more area than obviously manned walk around route-based kinds of inspections could be done. But again, I have to caution with that, because these, again, rely on being able to have a line of sight. There are certain applications that handhelds are still very much useful for, into areas that drones cannot, currently get access to. but in many cases, it can get access to places that a human being has so much more difficulty of being able to do that for the safety reasons and other things that Stan had pointed out. So these are just different manufacturers. Another area that's really growing is a couple of examples of companies that are using our product now for autonomous drone inspections, or some people refer to it as a drone in the box type of a solution. And here, these can be set up on, have specific waypoints and can do basically the same operation over and over and over again, very precisely. And then it comes back, it lands on a charging station, charges, and at the same time, it's uploading its information, to a program that now is managed by, a supervisor or a manager to be able to view any exceptions that occur, meaning that they find, some kind of a gas leak anomaly that needs to, to be acted upon. So you have that. In addition, I think other areas that you're going to see happen in the very near future will be oriented, especially with the advent of beyond line of sight, will be the potential use of what are called VTOLs, or vertical takeoff and landing systems, typically that can go into a fixed wing position. And again, will be a very nice benefit for, again, linear asset, longer range type applications. And then eventually probably into the traditional fixed wing applications. I'm kind of afraid to play another video. I'll just see, Stan, you can just tell me.
I'll reinterpret as needed.
Okay, just to show just some examples. I don't know if it's just doing one frame at a time or not, but the one thing I wanted to show here, if you can see this now, is some other great image processing capability that's been added. And especially with the stability of these platforms, you can utilize what we refer to as a gas enhancement mode that can colorize the gas, again, all in the effort of making it easier and simpler for an operator to be able to detect and visualize these gas leaks.
Yeah, that one right there, for example, you see the movement of the green. Jeff, we're only getting about a frame per second, but as you see, the green highlights there and the movement of the green, that is an indication of the gas plumes moving around.
Yes, thank you, Sam. I'm going to skip the next video here. Just as we have piloted or manned helicopters, another growing area is going to be fixed wing applications. Again, where you take because you have such a small, lightweight unit, you can integrate it into a gimbal platform, and you can actually integrate it with other sensors like visible light, rangefinders, hyperspectral, multispectral, other types of sensors. And I see a lot of integration of some different technologies in this capability when you have a larger platform. And these get down to more of your pipeline or linear asset type of inspections, where you have tens or hundreds of miles that need to be done. And these are the kind of platforms that I believe they're going to be very, very good for doing that. Again, because of the resolution, because of the sensitivity, we've done, and the addition of additional long range lenses. You can fly at higher altitudes, and you can fly a little bit quicker and be able to cover these long distances very efficiently with platforms like this. There's a couple of different examples of, again, crewed and piloted fixed wing aircraft. In the upper right-hand corner, of course, the staple application is using handheld products. But here, I think you're going to see lots of innovation as well, because again, reduced size, weight, and power of the instruments and the better resolution and the ability to integrate it into more modern platforms. In this particular case, this is integrated just with an Android phone, for instance. And down at the bottom is now a growing area, which would be robotics. And this can come in the form of tracked vehicles, or now, something that's becoming quite popular is this happens to be the Boston Dynamics people. It's referred to as the Spot. There's another company as well that makes a very similar product out there. And here, again, you can set this up on a very precise route. It does its operation exactly the same, every hour, every day, every week, exactly the same. And again, it simply collects the imagery, it stops, collects the imagery, and, then compiles that. And through change detection, through motion, various kinds of attributes in video analytics, edge processing, and AI, it allows this to be able to automatically be able to detect these leaks, record them, and then again, when it goes back to its charging station and then uploads its data, it enables companies to be able to automate their reporting and then the actions that come out of that, as well as combining it with other technologies such as sniffers or TD loss lasers, because this particular robot can carry many different sensors. And again, we see the inclusion of multiple sensor technology, and especially in the case where companies are wanting to not only detect and visualize, but they may want to quantify as well. So, then I think also going forward in the future, as the reliability and hopefully the affordability of optical gas imaging as it gets used more and more, that you'll be able to have more permanent mounted or continuous monitoring systems for process safety. And these are examples, for instance, again, where you can either integrate the cameras into in areas either with weatherproof enclosures or through ATEX class rated explosion proof enclosures, to either be fixed mounted or maybe to be integrated onto what's referred to as a pan and tilt positioner, where you can stop and stare and look, and at a whole series of different equipment. And not only maybe would you be able to just do optical gas imaging, but again, by combining it with other technologies, you would be able to, and because it's still just an infrared camera, for instance, in this image, you can actually see the tank levels. Well, again, with your AI and edge processing, you can create rulers, but what the distance is, so you can precisely indicate where the separation of those layers are. So not only is it finding the gas leaks, but thermally, it's being able to identify other anomalies as well. That could be in the form of spills in the berm, for instance. In this particular image on the bottom left, it could potentially be used for detecting hotspots on fixed or rotating or electrical equipment. It could be for verifying that the pilot is lit, for instance, on the flare. So again, this one instrument can be multitasking and do many different things. These are just examples of the OGI cameras that are integrated into various tower systems, whether they be skids, they would be trailers or permanent mounted structures. It is important in this particular application that you do get high and that you have generally a more downward looking view to be able to cover the area and the distance that you're wanting to be able to do. and so that you have a good perspective and you have a consistent background, as Stan mentioned, for being able to see the contrast between that.
Hey, Jeff, I'm going to pause there just for a second because
Okay.
I know that we are going to lose Jennifer at exactly
Okay.
10. So I'm not sure if people have questions, this would be the moment. And I apologize for interrupting there. I just know that we are going to have to say goodbye to Jennifer in exactly 6 minutes.
Yeah, and I may need to cut out right around that time as well.
Okay. So what I would say is any participant who raises their hand, I can actually turn on your microphone and let you ask the question live, or you can use the Q&A in the bottom of the screen to drop a question in there. While we wait for those responses, it might be if any of the panelists has a comment or a question for one of the others, this would be a great moment for that as well. There's so much good information here. You'll see in the chat window, I did put a link to our solutions page on our website. I also put an email address for Jennifer, as well as the link to the AIM page on the Colorado CDPHE website. I don't see anyone raising a hand. If there are questions, please take that moment now. Are there people in the panel who have comments or questions for one another?
Actually, I have a question for Jennifer. Jennifer, as far as Colorado is concerned, and as you look forward, do you see the state using OGI in additional manners? I know traditionally it's been used mainly from a handheld, and you did show continuous monitoring as well. But do you feel like that these aerial platforms are going to play an important role in your future?
Yes, it's entirely possible, Jeff, and forgive me, I'm not ahead of our technical services program, which does look at the monitoring on the capacities. I am familiar with several projects with a number of operators with different alternative technologies that are trying to coordinate with our division, including aerial platforms and drone mounted platforms. So I still do believe that drone mounts and aerial surveys are beneficial. We've learned a lot from our own. So yes, I do think it's going to play a large part.
Great, thank you.
Mm-hmm. So it looks like Matt has raised a hand.
Great, okay, Matt, you should be able to unmute yourself and ask your question.
Hi, I was wondering, I saw the handheld application. Who makes that, or if it's a actual producer that makes it and they developed it?
Was that the handheld application that Jeff showed on his slide?
Yes.
Jeff, can you comment on that? You're muted right now, Jeff.
Sorry about that. Yes, I can certainly indicate that. First of all, as Sue indicated in her presentation, she showed a lot of different models of different manufacturers that are available. That one is actually a new product, and it's through a company based out of the Houston, Texas area. It's called MFE Inspection Solutions. So you can reach out to them. You can just Google them, and you can certainly talk to them about that product.
Thank you very much.
You're welcome.
It looks like we have 2 minutes and I don't see any more hands raised or questions in the chat. So I would say with that, we'll just thank our panelists, Jennifer Mattox, Jeff Leake, and Stan Voynick. And of course, we want to recognize the micropilot group for putting together this meetup. And please stay in touch with us if you have questions. I will email a link to the recording of the webinar to everyone who registered.